there's anybody who actually have experience visiting Japan, I would like to discuss more about like the journey of Japan. But today I would like to demonstrate and describe some of the important factors of how to make your application perform well and efficient, and also about the user interface. And that's something I think most of you are very interested in. So that's why I choose my topic. And along with me, I was supposed to have introduce our TA, Andreas. He's actually sitting over there. He's also from Tokyo, Japan, and he knows much more Japanese than me actually. But he can help you if there's any weird English if I'm talking about, so that he can convert it to the very good native English. So I'm hoping him to correct my English as well. So let's start my. So my workshop is actually not actually a workshop. It's more like I'm talking and talking. But I also wanted to include some of the demos which I do from my from my personal computer. So maybe you can actually follow the same step if you're very interested in. And it looks like this session is also recorded. So maybe you can actually after this section you can just look at my video and try to figure out by yourself. So first of all, I actually wanted to do some survey. I mean, I wanted to ask you some questions that I've come up with. So would you please raise your hand if you have any issues while developing Cordova applications, or if you've got some if you get strict from your boss or your clients that your application does suck or something. Can you just raise your hand? How many? Oh, not that much actually. Maybe American people are very generous about application behavior rather than Japanese clients maybe. On our side, we've got, well, there's a long story because we started PhoneGap development since like 6 years before, and we have so hard time actually improving the performance. Back in that time, the things get pretty good right now. So that's why I'm very proud of describing our tips and tricks for those. But in general, some people still claim that Cordova doesn't work properly, or the performance is very bad, which is actually not. So that's my topic today. And I don't think there are any, but maybe it's very difficult to raise your hand, but is there anybody who actually stopped using Cordova or PhoneGap because of the performance, or maybe have abandoned? Oh, there is. Yeah. It's also happened to many companies in Japan as well, because they actually did so long evaluation time understanding how Cordova works, but they have to abandon because of the performance issues. That's also the case, which I also wanted to describe today, that it's not the case anymore. So today's topic is all about performance and user interface. So performance is more about a speed or responsiveness. So how smooth your application runs on your device, or maybe the client's device or the user's device, which is very important. So the thing you will do in that case is to optimize the application, obviously, or tuning up, what we say. Whereas user interface is not actually a performance, but it's more like a visual design, layout, or components where your application looks very smooth, or maybe it does feel responsive, even though the optimization is not yet enough. So for example, PhoneGap is actually very good for user interface because there are so many UI libraries. And actually, it's different than the web application. That's what I would like to talk about. But I wanted to say this is that if the UI is getting more complex, or maybe more friendlier to the users, usually the application performance get decreased because there are so many compilations, or there are so many renderings that have to be done in order to create a complex user interface. And hybrid application is not actually a web application. This is also very important because hybrid applications is more often compared to a native application. So people, all users actually compares things hybrid application as competitive to native applications, not to a web applications. because all programs and assets are stored on the device, it's actually not like a web application because the loading time is not that important. And we can actually display the screenshot, a splash screen, in order to hide the loading process, which is totally different than the web application. So in that sense, we can actually allow the application to wait until like 5 or 10 seconds in order to load all the components up and running in a browser. Whereas in web applications, all the web pages have to load instantly and draw very rapidly, which is actually pretty drawback compared to hybrid applications. So hybrid application is just using web technology to create a native application, but that means that people will care for the user interface and the native and the experience. So it should provide a good user experience as equivalent of native applications. So many front-end developers start to develop hybrid application nowadays. And back in a couple of years ago, what I said before, so there are so many data applications actually happening in Cordova or PhoneGap, which was very painful. But it's because of the it's actually because of the mostly is because of the computing power. So there is two devices. One is Xperia, the first generation, which I bought like 6 years before. Whereas the latest Xperia, which released recently, will have a very, has a latest Android operating system. When you run the same benchmark script, you will easily figure out that the latest Xperia have about like 15 times as quick as old Xperia devices within these 5 years, which means the Moore's law is pretty important, and we can expect that maybe next year, or maybe the following year, we will get maybe twice as quick device as we have right now, which means your application will behave twice as quick as the application right now. So this is very important. Of course, everybody has the latest device, don't have the latest device, but mostly, especially maybe in United States or maybe in Japan, people usually have the latest devices, and they like to replace their phones very quickly. So it's not actually so much issue for us because the mainstream devices still have a very good capacity at this moment and works pretty smooth. And also, there are very good reviews out there. Crosswalk, there is a session for Crosswalk, I think, in the session B, and also for K WebView. I think it's already including Cordova iOS platform and will be released as a stable release pretty soon. And it's using iOS Safari's WebView, which actually is a JIT compilation of the UI WebView. So instantly changing to this WebView, your iOS application will behave maybe like 2 or 3 times quicker as what you do at this moment. So there's a software optimization also happening in this world. And also there are many HTML5 improvements like CSS3 animations, WebGLs, GPU rendering, and also like script tags which can allow like async loadings. So those little tricks can enable developers to actually to build more performant applications than before. But actually, you have to learn quite many things to do those to include those improvements into your applications. So today, instead of describing those little techniques, I will actually wanted to describe what actually is causing the performance issues and user interface component issues, because this is some fundamental concept of web applications or hybrid applications, because they're relying on web platform, which means it's on running on a browser. So we have to understand how the browser is rendering your application. And that's the key factor for understanding how to improve the performance. So to solve those issues, to find out those issues, you actually have to do the tuning up cycle. So tuning up and tuning up and tuning up until you or your boss or your client or your user feels that your application is running pretty smooth, and I can give you 5 star for this application. So it's a long-lasting process. It never ends because there are so many techniques happening every year or maybe every day, and it's actually it's endless game, but that's how everybody is doing for improving the performance for the hybrid applications. But so there's a question is, how, as I mentioned before, so we need to understand what causes performance issues, and that's the main topic that I'm going to describe from here further. So to talk about the performance issues, um, or maybe to solve the performance issues, this is the effective workflow. Well, this is very straightforward workflow because you measure your own application, you understand your application, and you find where the bottleneck is and fix that issue and measure again to see if that fix improves. And then you can find another issue and solve the problem, and then finding another issue, so on and so on and so on. So this cycle actually, step by step. So there's no like, golden rule, but this actually, there's no silver bullet, way to solve every issues one time, except like changing Crosswalk to like WebView to Crosswalk or iOS, UI WebView to WK WebKit. But most of those tricks have been already covered by the platform side. So the application side have to do this kind of like long running marathon kind of fixation in order to to fix those small things one by one. But that is very important. So I would like to describe how to find the bottleneck, and from here I would like to describe how we should improve, how we can find the bottleneck and how to improve those factors. So finding a bottleneck it's pretty actually it's already on your hands actually. So using debugging tool available. Um, okay, I got a better mic. So find So finding a bottleneck is pretty easy because your computer already have installed this device, this tool called DevTools. If you're using Android, or Safari Inspector if you're using iOS, and you just enable USB debugging on your device, and you plug in using USB and visit Google Chrome and inspect your device. Maybe most of you already have done this before. Um, but what's interesting is that, so maybe most of you have dealt with like, DOM inspections or maybe consoles, but also it is timeline feature is more important to find bottlenecks than those other, commonly used components. So click on timeline. I will show you later. So when you click on timeline, it will show you how the application is running, how the web browser is rendering or calculating or maybe composing your application for outputting the content. That is how the this is the example of Chrome Dev Tools, and you understand you see some bars or the charts, which if you look them carefully, you will understand where the bottleneck resides within here. So I will just describe some of the example for here. So before understanding this, we have to understand about the timeline. So here's the typical browser flow. So browser, of course, loads the script from your local device. I mean, your local application. That's a loading phase, and it does scripting, which executes JavaScript, and then it renders, and then it paints. So this is considered as a one frame, and it is ideal if this operation finished within 60 milliseconds because it is good to have 60 frame per second rule to keep the application running so that the user don't get frustrations or the application does behave very smooth. So it is pretty important to make this cycle within 60 milliseconds. And to figure out how those, to understand about, those those categories, I would like to describe one by one and describe how to solve those issues. So this loading process is more like, it's a time spent when loading resources or and parsing the HTML. So hybrid application usually have no difficulty. Actually, I mean it's relatively slower, faster than the web applications because all the assets HTML5 and JavaScript is actually resides on the device. So usually this loading issue is not actually making an issue anymore in the hybrid applications. So I don't say so much about these loading issues. But for scripting issues, this is one of the important factor. So this is all about the JavaScript execution time. And maybe back in many years ago, everybody claimed that JavaScript is web application is slow because JavaScript is slow. But actually, it is not that true anymore. Because if you compare JavaScript and maybe application written in maybe C++, maybe you will find no difference between the application running in those two programming languages, which means JavaScript is already pretty quick because Google and all other companies like Microsoft and Apple is devoting so many resources to include latest execution engine into JavaScript engine, so that like Google's V8 or Safari's Nitro or Edge, those Edge Chakra, so those perform pretty much quick than the browsers that back in like 3 or 4 years before. So JavaScript engine itself is not that not very slow, but actually what causing the execution time slow is something like if you want to draw something on a canvas, or if you want to access to a disk, or maybe if you have to reflow, which I will talk later, if that results to a reflow, then it's not actually a JavaScript issue. It's more like a browser rendering issue, and it's getting very less performant. And also synchronous calls. There aren't so many synchronous calls, but like, if you do console log, or if you do alert, or if you do like document write, those will spoil the scripting issues as well. So how do you find if your application have a scripting issue? The answer is to use the profile tab in the DevTools. So profile tab, which I will also show you later, describes what kind of JavaScript logics are running within the specified amount of time. So of course you have many functions that you implement, or many APIs that you're calling to a browser. So the browser measures all the calls to those functions and measures how many times taken for each function to finish, and you can arrange by you can sort by the execution time. So the larger number of so the higher you get in this result means there are much more possibility for you to solve the performance issue, and that's how you're finding the bottleneck for JavaScript, which is pretty obvious for those users who have used profiles before. But it's also very useful for web developers as well to make use of this profile tab. So this is more into the script tag. So what we usually do, so filter by, so we see the self section in the left because this is what the actual time spent on each function, and then sort by bottom up so that the upper you go, more execution time is taken. So for this example, this is idle, so this is okay. But here, there's an anonymous function that's taking around like 80 milliseconds. So it might be not so effective to reduce its amount of time, but if there is any milliseconds happening in some specific function, you can consider tweaking it to resolve the JavaScript execution time issues. And it's pretty good to just try profiling your application to have a general overview of how your applications are used, how the CPU is used when running your applications, actually. And going to the rendering issues, this is a third process for the workflow for the browser. And rendering is actually a layouting process. So first browser loads the HTML, and then they execute JavaScript. And now the browser is trying to render the DOM tree for the visual output. So rendering is a layout process. So what they do, they will get all, so CSS, so they will first recalculate the styles. So CSS rolls to the element. So browser have to figure out what element have which CSS styles applied. And then they will render according to that render tree generation. So that's where it is, so that's why CSS size is pretty important. So browser will calculate what styles to apply to the specific DOM element. So number of DOM elements times number of CSS rows will result into the CSS object model. So that's why if there are so many unnecessary CSS rows that is applied to your, written in your application, maybe you should remove those CSS styles. If that is also applied to so many number of DOM elements, it's the risk of getting slower is is getting more higher risk to get your application very slow. Or if there are so many CSS rows that have so many heavyweight CSS rows, you should also avoid doing it, but make it as a more light and compact CSS rows, which looks like exactly the same, but you can have many ways to write CSS, and which also is very important for reducing the style recalculations. And also layout is also generating render tree, and this is also important because layouting render tree is something like browser now get the CSS information and adapts the style. So they will create the visual render tree within the memory, like imagine like a GPU, rendered in each layer. So that's the layouting process. And it is no good way to reduce the speed of layouting process because this is heavily like GPU or CPU intensive, and this is what the browser is always doing. But again, if there's of course less DOM elements in your application, less render trees are created. So that means your application will get much quicker than before. Mm-hmm.
Way that it renders with the DOM versus something else.
Yeah, so I actually haven't covered frameworks yet, but yeah, so for example, like consider React or maybe AngularJS. So the times, if you profile, you will figure out that the time spent on their rendering actually is more to the JavaScript side than a layout side. Because once they inject into DOM, browser will do everything for you. And for example, React is actually using inner HTML to inject every, the snippet, the DOM snippet, because inner HTML is much quicker than create element. So that's why I think they figure out to use inner HTML instead. So in that case, they're relying everything on browser to render the newly created elements. So, but yeah, they're more like have a stronger impact on the JavaScript side than the DOM or the CSS rendering side, I assume. But there are so many frameworks like previously like jQuery mobile was pretty popular, and jQuery mobile have so many like CSS roles or so many JavaScript side renderings, which actually cause the application behavior a little bit slower. So those should be translated to like CSS3 renderings or something. Yeah. So painting issues. This is the fourth process that the browser is doing. So finally, once the browser has the render tree, it will draw it. And this is how Chrome is doing. This is actually written pretty precisely in their document, actually. But they first convert the rendering into the list of commands. So they now change those commands to like move to or line to or fill to or something like that. It's called like Skia if that's a Chromium. So they create the display list. and they rasterize using GPU power, and then composite layers using GPU power. So that's how they draw. And this is pretty quick if they can use full power of GPU from GPU spec. So it's not an issue if this painting can be done everything in GPU, but if the GPU have not enough maybe GPU memory to render everything, then they have to use GPU. So the performance drops pretty much. So I remember like a couple of years before, a framework called Famous. There's a Steve Newcomb. Maybe you remember. He taught to everybody that not use GPU renderings. It's because GPU is pretty like fuzzy thing that once the GPU capacity have exceeded the actual application size, then the application behaves so slow. So that's why they said they decided to use the GPU renderings instead. But maybe those things might happen when using renderings in a very large web applications. So those are some important factors, and I think I would like to do a little bit demo for what I described so far, so that you can have more understanding of how it looks like. So I want to let me see if I can display my application. Okay. I'm actually using my real device because real device actually does more than, tells more than the simulators. So to open the diff tools, you just use Chrome inspect. That's what you do usually. So it is connected by USB. So I see my debugger running here. So I click on inspect button. Maybe it's a little bit hard to see because the screen is a little bit small. Here we go. Okay. So the application is something like this. This is like a application. This is actually the real contact list application which we've created for demonstrating material design. This is completely written in HTML5. And this actually loads Cordova using Cordova API to actually load my contact within this application. So this is my private information, unfortunately, but they're in Japanese, so I think it doesn't care for you. So when you click on this, you will see the information here with his name. What I can do here is I will go to timeline. Here we go. So let's see. I want to check how it works if I click on here. In this case, I click on recode, and I click here. I'm doing on device and stop. Unfortunately, it doesn't show up here, but actually I changed to a newer page. Okay, and my profiling has finished, and this is a consequence. So when I see this, okay, here it is. So if I see here, so there is an event here. Maybe it's hard to see. It says touch start. So because I tap the screen, and it actually does a function call, and it recalculates style and updates. So the colors here represent the process that I described later. So this is the painting. So as you see here, if you look this carefully, you will see what kind of tasks are running within the browser within this only like 100 milliseconds of time, which is very short, but it's very long for the GPUs or CPUs. So that's why they're measuring this. It's actually for this application. It's actually we pretty much optimize this application. So that's why there aren't so many places where it feels like very slow. So that's why maybe it's not a good example. But if you actually look carefully, you might find some glitches in these function calls here. Somewhere like here's some bug in Chrome DevTools maybe. Okay, here we go. I'm actually did the profiling again. Something weird is happening here. Okay. Here we go. So if you see the overview, it's scripting takes like 70 milliseconds, which is not very small actually, because we have to take all the JavaScript array because the contacts are in the array and it's taking the array and displaying the information. So maybe there's a way to solve this milliseconds, but for the renderings, from here I would like to tell you how to reduce the rendering size, because this is the most important part here, rendering, because the painting is pretty quick because because I said that this is more like a GPU intensive, but rendering can happen anytime. So I want to describe how to reduce this rendering from here with a demo. So first, maybe somebody here had heard that Translate 3D is very quick, and it is because many people say that because GPU is used, but actually GPU usage is not the key factor for making the application quick. It is partly true, but more the reason is because transform CSS properties only do composite manipulations. So as I mentioned before, composite is something that composites the already rendered trees. But it is more taken time to render that render trees. So in order to avoid the render tree, what we call reflow is more important. So we have to know which CSS properties change will trigger to some of the impact in the performance. So that's why there is a very good website called CSS Triggers. And I want to describe a little bit for this, because this is how we also try to see and use the appropriate CSS to avoid the performance issues. So for example, very easy way, like something like left. So left property, makes the object move to the left. And there's the three little dots here. This tells that there's this purple is layout, and this green is rendering, and this is composite. So if there's a property that ends up doing from the layout phase, then all the DOMs have to be recalculated again, and that impacts performance so much. So that's why there are so many properties that causes layouting change, but also there come some properties that doesn't cause layouting change, like transform or translate. So that's why we tend to use transform in order to make the CSS renderings much quicker. But all of them actually triggers composite. So that's why composite is inevitable. But almost all the composite can be done in GPU side. So that's why composite process is not that slow as all other processes that require CPU. And then reflow. This is what I mentioned, and this is very important, because reflow is the process that when you change the CSS style something, some style CSS change, then it automatically, and then all the other elements have to be recalculated, and thus impact on the performance too much. And it's not only when you when you change the CSS properties, but also like when you read off, like for example, like offset height from JavaScript, or maybe if you call get bounding rect, they will call reflows. So that's why there is one technique that we have been using is to detach the element from DOM tree. So you do remove element, but still keeping the element as an array, as a JavaScript object, and manipulate that object, and then insert it back to the DOM tree. Then all the reflows can be avoided, and just one reflow, and the application just do the only one layout, which is much quicker than running reflows every time. Like so don't do like within the loop, don't do something like reading offset height or reading style information from the CSS from JavaScript. That will cause reflows all the time, and that has a performance impact so much. So back to the example, I want to tell you the JavaScript execution side as well. So going to the profiles and art. And I'm waiting for, okay, stop. Okay, here it is. So I created a profile to read this application. So it took about like maybe 10 seconds to completely show all my contact information. And you could see that almost like 60% is the idle time. But you see some like functions calling inside the like it's an on-same function actually, doing the initializing the alert dialog, and also some anonymous function inside the app controller because I'm using AngularJS for this application. Yeah. So something like this append child. So this actually takes like 27 milliseconds, and I mentioned that one frame should be within 16 milliseconds, but it's already taking like 27 milliseconds. So there is a good enough chance for me to think of not injecting child one time, but injecting in separate times in order to make it more efficient. Yeah. But yeah, usually what we do is we usually notice by using this application where it's slow. And we want to figure out why this is slow. And we pick the target, and then we do the profile or timeline. In that case, we can more easily, not I will say easily, but we can usually find the cause of the, find out the cause and figure out how to fix those issues. But in this case, because I actually already have created pretty much performant, so that's why it's pretty difficult for me to find the issues so far. But yeah, so this is how to use the diff tools. But so as I talk again here, maybe most of you guys actually feel very too difficult to optimize because you have to understand how the browser renders and how to avoid reflows, which means you have to be super careful about manipulating CSS. But so that's why I and my team have been doing this for many years. So we have been thinking how we can do those, more easier way to handle those performance issues, so that the user UI library don't have to, so that the user don't have to, to solve those performance issues by yourself. So that means UI component can solve those performance glitches, and users can write your own source code without having to deal with those understandings, because those are too much complicated and those are too difficult for everybody to understand. So that's why we're now creating UI framework called Onsen 2. So this is a little bit more like a sales talk, but please cope with it because this is also very important. So we actually firstly started using Angular 1. But actually Angular 1 was okay, but it was not super performant. Actually, in order to create an application that runs pretty well, we have to quit AngularJS, but use our own framework, or maybe just using plain JavaScript, or maybe using some easy libraries like Vue.js or maybe Zepto.js or whatever. So that's why we actually started this UI library version 1 using Angular 1 dependency, but from version 2, we're thinking to remove all the dependencies for Onsen UI for AngularJS, but only stick to the pure web components. So now there is no two-way bindings, and there is no good MVC framework embedded into the UI library. But on the other hand, we can get so much smooth and sleek user interface, and the application loads much quicker than using AngularJS. So, but we still can use Angular 1 or Angular 2 because it's just a pure web collection of web component. So if you get interested in, please try out, and maybe you can download and try out yourself. So one of the examples that we've been devoting is something like component called once lazy repeat, which provides the infinite list scrolling, which is pretty important for the hybrid applications to render the infinite list. So
sorry, what does that lazy repeat do?
So it does. So that does something like this. So the list so think of a list having 1 million records of data. We cannot put all the 1 million elements into DOM. So we have to tweak, when to display or when to hide. But it is very difficult to do those on the user's end, the developer side. So that's why we encapsulate those into the libraries and provide those as a component using the web component.
And so Onsen does this
Yeah.
for you?
Yeah, for
that lazy load?
Yeah, so we do the lazy load. So that's why the user don't have to implement those. So we have some components like this. Maybe I can demonstrate this later. So we load the element when it's about to show, and we hide the component when it's going to be disappeared. So that you can, it's in theoretically you can have infinite list, of course, because they're not attached to the DOM.
Have you performance tested that?
Yeah, I can show you the test. Maybe I have a project here.
I just mean, have you done benchmarks to what's the performance
compared to the usual DOM?
Yeah.
It won't work. So obviously, yeah. Okay, here we go. So here's the application. This actually have a million list size. I don't know how smooth screen transfer is, but if we can keep on scrolling and scrolling and scrolling until I don't know. I think this has a million items, but yeah, it's very smooth. Yeah, if you see this in real device, it's more smooth than this actually. Yeah. So something like this. So we have so many components like this to speed up your performance. And I think those are very important to reduce the amount of the work that developers have to do, because those are some common cases for the developers to implement, but we don't want to, additionally include any more JavaScript libraries in order to just do this thing. So that's why we just written in pure JavaScript with component and make it used for everybody to use it without, framework dependencies. So there are so many components like this. We have grids or forms or controls, or also lazy repeat is one example, but we also have material design, tab bars or navigation bars. So maybe if you wanting to get us a chance, you can come to our website and download the starter kit so that you will experience how effective it is to use our UI libraries into your applications. So that's my end of my talk, and thank you very much for listening. That's the end of my show. Thank you. So shall I ask for any questions? you have 5 minutes.
Yeah, 15.
Oh, really? Oh, I thought it's until 35.
Yeah.
Okay, yeah. Wonder if anybody have questions or any issues? Maybe also Andreas can help us because he's also managing also UI. Okay, sure. Oh, I see a person there.
Yeah, I guess in terms of overall performance and feel for the user, how do you prioritize like 4 different things that you can find in the tools?
Right.
In the timeline, yeah.
Yeah. So one example, I cannot disclose the client name, but it's a very famous mobile phone handset maker. They wanted us to do the consultation for the performance. So I asked for them for the priority, and they usually say that they don't have any priority. They just want to get it quick. So that's why what we usually say is that so tuning up is actually very important process, but it's more important to understand that your developer can to speed up the things. So that's what I'm telling them. And in order to prioritize on our side, it is pretty important. It is pretty. We usually see the review in the application and how they're where they're claiming. Maybe it is only in Japan, but there are lots of people actually telling where the application is behaving slow. That's why it helps us a lot where to improve. Yeah, because I cannot improve everything for sure.
Yeah. A couple of years ago, we were deciding on a project whether to use CSS3 or GreenSock for the same animations. And a lot of people were claiming that CSS3 was faster at that time, and we ended up going with GreenSock. And then the day we finished the project, Apple changed how Safari worked, and all those CSS3 optimizations went away suddenly. GreenSock continued to work at the same speed because they have some intelligent thing going on that like sometimes uses JavaScript, sometimes uses CSS to get the best performance. Can you talk a little bit about frameworks like that are obscuring some of those details, some of those, and how things are changing over time? Because at any minute, that CSS trigger site, they could just change all the information, and now everything we did based on the old information is wrong.
So yeah, so it's up to the browser vendor how they interpret JavaScript or CSS in renders actually. My experience is that yeah, that's a very good question. So yeah, there's always the debate between whether it's good for doing CSS3 rendering or the JavaScript side rendering always. Because CSS3 is pretty difficult to control ourselves. I think that's the bad aspect of CSS3 renderings. Whereas JavaScript rendering, if we do request animation frame, then I heard this in from this article somewhere, but so they say that the older devices will be running at 3 frames per second, whereas the high-end devices will run on 60 frames per second. So, and they say that even like a 60 frames per second application can be good, but if they once get to 30 frames per second mode, then the user will be very, very frustrated. So that's why they say request JavaScript animation frame is better than doing CSS animations. And I think it's something Andres told me today that Polymer project is using JavaScript renderings rather than CSS3 renderings.
I read some of the code and they
don't
use
So I think there is no definite answer to it, maybe, of course, but I will say CSS3 animations might get trouble if there are so many layers and there are so many composites. That's how I interpret actually. I forgot the size of the Safari, as for the latest device, but actually it also depends on the model of the device actually. So the older models have lesser GPU memory, So that's why their composite might be driven by CPU in some time. So yeah, it's pretty hard to tell. Yeah.
I mean, just to follow on, it seems like there's a lot of things with JavaScript that you couldn't do with CSS. I'm thinking of maybe having, like, if the render time starts to slow down, you could detect that with JavaScript mid-animation and say, oh, well, don't render this half of the things, only render these. You know, like, decrease the amount that you're trying to render in order to let the device speed up, where CSS, there's no kind of controls like that. So yeah, to your point. Thank you.
But from my point of view, actually, the device, so Moore's law is actually very, it's promising because maybe next year we have more better GPU, more better CPU, more better memory. So eventually, I think GPU rendering will conquer the application, renderings. That's how I'm feeling in the future, actually. Okay. Any other questions? Okay. All right. So that's it for my workshop. Thank you very much for attending to me. Thank you.